Alright, Chapter 2, Wiring Techniques. Learning Objectives. Upon completion of the chapter, you should be able to save the basic equipment to any splice terminal connection, including the preferred wire stripping methods. Straight the reason for the ends of the wire are clamped down after the Western Union splice has been made. Explain the major advantage of the crippled terminal over the solder terminal. Explain the major advantage of crip terminal over a soldered terminal. Name the two types of insulation commonly used with non-insulated splices and terminal lugs. State the advantage of using pre-insulated terminal lugs or color-coded for use for each, and the color code for use to each. Explain the procedure for the crippling terminal lugs and hand crippling tool. Recall the physical description operating procedure for the HT900B, 920B compressed and air nitrogen heating tool. Recall the safety precautions for using the compressed air nitrogen heating tool. Recall the procedure precautions tools associated with the soldering. Explain the procedure for the precaution of the tinning wire. Recall the types of the soldering irons and the uses. State the purpose for the required properties of the flux. State the purpose for lacing conductors. Recall the double lacing wire bundles as required. Recall the requirements for use of spot ties. Wiring techniques. The chapter will assist you in learning the basic proper wire techniques. Explain the different ways to terminate splice electrical conductors. It is also discussed the various soldering techniques, which will assist you in mastering basic soldering skills. Chapter ends with a discussion of the procedure to be followed with your lace wire bundles with electrical and electronic equipment. Conductor splice and terminal connections. Conductor splices and connections are essentially part of the electrical circuit. The conductors are just joint either each other or connect to a load. Splice terminals must be used. Therefore, it is important that they are properly made. Electrical circuit is only as good as the weakest link. The basic requirements of any of the splice or the connection is that both mechanically and electrically are sound combined as the conductor or device which is used. Quality workmanship material must be used in ensuring lasting electronic connecting contact, physical strength, and insulation. The most common methods of making splices and connections, electrical cables is explained in the discussion that follows. Alright, your insulation removal. The preferred removing insulation with the wire stripping tool is if available. The sharp knife may be used. The other type of wire stripper that are used in the Navy, illustrated in Figure 2.1. Hot blade rotary bench wire strippers view A, B, and C respectively, usually found in shops where the large wire bundles are made. When using the automatic wire stripper, the file of the manufacturer instruction for the adjusting machine. Avoid nicking, cutting, other damaging with the conductors. Hand wire strippers are common hand tools found throughout the Navy. Hand wire strippers, figure view D2.1, are the ones that you most likely be using. Wire strippers are in size according to the wire size and can be ordered for any size needed. Figure A would be your wire stripping tool. B would be hot blade wire stripper. B, rotary wire stripper. C, bench wire stripper. Withdraw wire to the strip. Blade holds pivot to allow the wire insertion, and hand wire strippers in D. The procedure of stripping wire with a hand wire stripper is followed. Figure 2.2. Insulating cutting jaws length with the terminal barrel. Direction of the jaws for insulation is cut, and the cable gripping jaws. And step 1, select the correct hole with the match the wire. Step 2, blades remain open until the wire is removed, and be careful not to nick or cut the strands. And 3, insert the wire with the center of the correct cutting slot with the wire side of the B slot. Strip. The wire size is listed in the cutting jaw with a hand wire strip beneath each slot. After inserting the wire with the proper slot, close the handles together as far as they will go. Slowly release the pressure as not to allow the cutting blade to make a contact with the strip of the conductor. And once some of the newer style handles wire strip of the cutting jaws have a safety lock that helps prevent this from happening. Continue to release the pressure until the gripper jaws release the stripped wire, then remove. Or knifing strip. A sharp knife may be used with a strip of the insulation from a conductor. The procedure is much the same as sharpening a pencil. The knife should be held at approximately 60-degree angle of the conductor. Use with extreme care when cutting through the insulation. Avoid nicking or cutting the conductor. This procedure produces a taper or cut insulation shown in Figure 2.3. Alright, knife stripping, right? I'm wrong. Locally made hot wire stripper. If you are required to strip a large number of the wires, you can usually locally use a local hot blade stripper as follows. Alright, you have the 2.4 local made hot stripper with a 4-inch, approximately 1/16 inch drawn copper strip. And so if the end of the power strip piece of the copper strip to cut it to the edge of the V. At the bottom of the V, make the wire slot a suitable diameter of the size wire to be stripped. Fasten the copper strip around the heating element of the electric soldering iron shown in Figure 2.4, and the iron must be rated at 100 watts or greater in order to transfer enough heat to copper strip to melt the wire insulation. Lay the wire with a cable strip to the V, and a clean channel will be melted in the insulation. Remove the insulation with a slight pull. General wire stripping instructions. Alright, when stripping wire with any of the tools mentioned, observe the following precautions. Do not attempt to use a hot blade stripper on wiring, glass bladed, or asbestos insulation. Insulators are highly heat resistant. When using a hot blade stripper, make sure the blade or clean blades will with brass wire brush as necessary. 3. Make all stripping blades are sharp and free of the nicks and dents and so forth. When using any type of the wire, strip the hole of the wire perpendicular to the cutting blade. Make sure the insulation clean cut, no frayed, ratchet edges, trim as necessary. Make sure the insulation is removed with the stripped area. Some of the types of wires are supplied with a transparent layer between the conductor and primary insulation. If this is present, remove it. When hard strippers are usually removed, the length of the insulation longer than 3/4 inch for the strip procedure must be done to a more operation. The strippers will only strip about 3/4 inch at one time. Retwist the strands by hand if necessary. Restore the natural layer tightness of the strands. Strip the aluminum wires with a knife. And described earlier, aluminum wire should be very careful. Should not be taken. Care should be taken not to nick the aluminum wire, as the strands break very easily when nicked. Type of splices. There are 6 commonly used types of splices. Each advantage, the disadvantage of each of her use. Each of those splices will be discussed in the following section. Alright, you have your Western Union splice. The Western Union splice joins small solid conductors. Figure 2.5 shows the step in making a Western Union splice. Figure 2.5 shows the splicing union. Prepare the wire for the splicing. Enough of the insulation to remove to make the slice. The conductor is clean. Bring the wires to cross position. Make a long twist, and then in each wire, wrap one around the other, and then the other end 4 or 5 times around the straight portion of each wire. Press the end of the wires down completely and close possibly the straight position of the wire. This prevents sharp ends of the puncture tape, the covering of the wrapped over splice. Then the various type of the tapes and theirs are usually discussed later in this chapter. Alright, your staggering splices. Join small multi-conductor and cables often problem. Each conductor must be taped, and if the splice is directly opposite each other, the overall side of the joint becomes largely in bulk. A smoother and less bulky joint can be made by the staggering of the splices. Alright, figure 2.6 shows how 2 conductor cables join with a similar size cable by using Western Union splice. Staggering splice care should be taken to ensure that the short wire from the one side of the cable is spliced to a longer wire from the other side of the cable. The sharp ends of the clamped firmly down on the conductor. The figures show the Western Union splice, but other 2 splices work just as well. So you do a Western Union on the long, and you give it a long and line staggered, long and short wire staggering splices, Western Union style. Alright, rat tail splice that is used in the junction box with the connection branch circle the joint, rat tail joint in figure 2.7. Bare wires twisted. Wires that are installed in buildings usually placed inside the long lengths of the steel and aluminum pipe called conductors. Whenever the branch multiply circuits are needed, junction boxes are used to join. To create a rat tail joint, first strip the insulation off the end of the conductor to be joined. You then twist the wires to form a rat tail. Effectively, the type of splice will not stand much stress. Alright, a fixture joint is used for connecting small diameter wires such as lighting fixtures into large diameter used for the branch to a large diameter wire used for the branch circuit. Like a rat tail, the fixture joint will not stand much strain. Figure 2.8 shows the steps in making the fixture joint. The first step is to remove the insulation and clean the wires to be joined. After the wires are prepared, the fixture wire is wrapped a few times around the branch wire, and then the end of the branch wire is bent over the complete turns, and the remainder of the bare fixture wire is wrapped over the bent wire, and soldering taping completes the job. So you have the bare wires, branch wire cross, main wire bent over, and then fixed wire wrapped around the hook. Alright, your not a tail joint. All splits discussed up to this point are known as butted places, each from which is made by the joining of the free ends of the conductor together. Sometimes, however, it is necessary to join branches conductors to a continuous wire called the main wire. Such a junction is called the tap joint. The main wire to which the branch wire is tapped is about 1 inch of insulation removed, and the branch wire is stripped to about 3 inches of the insulation, and the not a tape tap is shown in figure 2.9. The branch wire is laid behind the main wire with the free force of the bare wire portion of the branch. Wire extends above the main wire. The branch wire is brought under the main wire and around itself, and then over the main wire to form a knot. The branch wire is wrapped around the main conductor in short, tight turns. This end is trimmed off. The knotted tap is used where splicing is subject to the strain or slippage. When there is no strain, the knot may be eliminated. Alright, wire nut and split bolt splices. The wire nut view A, figure 210, is the device commonly used to play with the rat tail joint displays. The wire nut hose housed in plastic insulation material. To use the wire nut, play with the two strip, the conductors, and the wire nut, twist the nut, and then doing so, this will form a splice like a rat tail and insulate itself, drawing the wire insulation of the wire nut insulation. So basically, you have a wire nut, and then you split the conductor, split the split bolt splice figure view B is extensively two large conductors in the illustration shown replacing the knotted tap joint. Split bolt piece can be used to replace butted splice mentioned previously when using large conductors. Alright, your splice insulation. The splice we've discussed so far usually insulated with the tape. The following discussion over the covered some of the rubber friction or plastic insulation tapes. Rubber tape. Latex rubber tape. The splicing compound used for the original insulation was rubber. The tape is applied to the splice with light tension so that each of the layer tightly against one underneath. The pressure causes the rubber tape to blend into the solid mass. Upon completion, the insulation similar to the original is restored. And roll form the layer of the paper-treated cloth between each of the layer of the rubber tape. The layer prevents the latex from fusing while still on the roll. The paper and the cloth is peeled off and discarded before the tape is applied to the splice. The rubber splice taping should be applied smoothly under tension so no airspace exists between the layers. Start the first layer near the middle of the joint instead of the end. The diameter of the completed insulated joint should be somewhat greater than the overall diameter of the original wire, including the insulation. Alright, warning, some of the rubber tapes are made as a special application of these types of semiconducting which will pass electrical with represent shock hazard. These type of the tapes are packaged similar to latex rubber tape. Care should be taken with the insulating splice only with a latex rubber insulating tape. Alright, friction tape. Putting the rubber tape over the splice means the insulating has been restored to a great degree, and it is all necessary to restore the protective covering. Friction tape is used for the purpose of all provided with a minimum degree of electrical insulation. Friction tape, the cotton cloth has been treated with a sticky rubber compound. It comes in rolls. Some of the rubber tape, except for the no paper and cloth, are separated. Is used as friction tape. Friction tape is applied like rubber tape, however, it does not stretch. Our friction tape should be started with slightly back over the original insulation when the tape should each for the turn overlaps one before it. Each extend the tape over the insulating other end of the splice. From this point, the second layer wound back along the splice until the original starting point is reached. Cutting the tape firmly pressed down and to complete the job. The proper care is taken that the splice insulation can take as much abuse of the rest of the original wire. Or your plastic electrical tape. Plastic electrical tape has come in wide use of recent years and certain advantages over the rubber and friction tape. With example, to withstand higher voltage given the thickness. Single thin layers of the certain plastic tape will stand several thousand volts without breaking down. However, to provide an extra margin for safety, several layers are used to run over the splice. The extra layer of the thin tape add very little bulk. The additional layers of the plastic tape provides added protection normally furnished with a friction tape. Plastic electrical tape usually has a certain amount of stretch so that it easily conforms to the contour of the splice. Your terminal lugs. Since most cable wires are stranded, it is necessary to use the terminal lugs to hold the strands together, aid fastening the wire's terminal studs. The terminals used in electrical wiring are either soldered or crimped. The terminals used for the repair work must be in the size and type of the specified electrical wire diagram, particular equipment. Alright, so you have a right angle, flat, the terminal lugs and splices. You have a right angle, a flag, a splice with a barrel, tongue, and vent, and a terminal stud. The increased use of the cramped terminals is due to the limitation of soldered terminals. The quality of solder connections depends mostly on the operator's skill. Other factors such as temperature, flux, cleanliness, oxidized, insulation damage due to the heat, also due to the fact of the connection solder type. The connections are covered later in this chapter. As advantage of the Krip-on solderless terminals is that they require relatively little operating skill. Another advantage is that the only tool needed is the crimping tool. This allows the terminal lugs to be applied with a minimum time and effort. The connections are made rapidly and are clean and uniform construction. Because of the pressure exerted by the material, the crimped connection splice properly made is mechanically electrically sound. Some of the basic type of the terminals are shown in Figure 211. There's several variations of the three basic types, such as the use of instead of the terminal hole 3 and 4 sway splice type connectors or others. So the Navy uses both copper and aluminum wiring. Both copper and aluminum terminals are necessary. Various size terminals, stud holes that may be found with each of the different wire size. A further reinforcement of solderless terminal splice and insulated type. The barrel and terminal splice is enclosed with the insulated material. The insulation compressed along with the terminal barrel when it's crimped, but does not damage it in the process. The ridge of you need for taping, tying insulation sleeves over the joint. There are several different types of crimping tools used with copper terminals. However, you will normally be concerned with only with the wire side of the American wire gauge 10 or smaller. For the wire of these size of the small plier type crimpers used with the uninsulated terminals are shown in Figure 212. The small plier type crimpers have several types of notches for different size terminals. Care should be used to select the correct size of the crimping tool with a particular terminal. Alright, so the strip wire, the added terminal, and then use the female nest and staking dies. And the compressed terminal 1. Use the tool and compressed terminal 1. Figure 212 show the crimping small copper uninsulated terminals. Non-insulated terminal splice insulation. Non-insulated terminal splice are used with some form of the insulation must be used to cover the bare conductor. The two most common forms of insulators used with the terminal splice and transparent tubing, commonly called spaghetti. Heat shrinking tube. If the spaghetti is used, it must be tied in lacing twine, and it is illustrated in Figure 213. Heat shrinking tube is shrunk to the desired size by applying dry heat. Always a good way to insulate terminals and splice, illustrated in Figure 214. This tube shrinking approximately one half the original diameter when heated with the electrical hot air gun. Figure 215, there are steps of using the hot air gun. The lacing twine and spaghetti, 1/2 inch, approximately 1/4 inch spaghetti, and then 1 inch tight and shrunken sleeve. Reflector, typical hot air gun. Hold the heat source 4 to 5 inches away from the wire. Apply 275 degrees to 300 degrees Fahrenheit for about 30 seconds. Rotate the wire while applying heat so that the heat is evenly distributed. Remove the heat as soon as the tube conforms to the shape of the wire. Allow the tubing to cool for at least 30 seconds before handling. Caution: do not apply hot heat greater than 300 degrees from the may damage the wire. Do not continue to apply heat after the tubing is shrunk onto the wire. Further application of heat will not cause additional shrinkage of the tubing. Compressed air nitrogen heating tool. The compressed air nitrogen heating tool is a new tool in the fleet. Was designed as a portable source on the heat. The tool is safe and used under fueled aircraft because of the opening heating element is not required. The compressed air nitrogen heating tool can only be used on the compressed air nitrogen heating tool can be used on heat shrinking tubing. Alright, so the 216 shows a compressed air nitrogen heating tool. The air inlet nipple, the dust cap, the air regulator, the heating gun, the power lamp, the air pressure gauge, and the reflectors, power switch, heat air on lamp, and temperature control knob. The compressed air nitrogen heating tool comes with two styles: AC or DC electrical supply, power supplies. The power requirements listed in Table 2-1, both styles. Electrical power HT900B, 115 volts AC, 50 to 400 hertz, single phase 7 amp. Electrical power HU920B, 220 volts AC. 50 to 400 hertz, single phase, 3.5 amps. Heat gun out of temperature 550 to 920 degrees Fahrenheit. Compressed air nitrogen 80 to 200 psi gauge 4 SCFM, dry and oil free. Alright, refer to the operator's manual of safety operating procedure for the compressed air nitrogen heating tool. With a brief summary of these procedures followed. Push down fully and turn the air regulator knob the counterclockwise to ensure that the air regulator is off. Remove the dust cap from the air inlet pipe. The inlet pipe will reconnect the air with the nitrogen source line. Warning: if nitrogen is used, make sure that you are in a well ventilated area. Use the nitrogen poorly ventilated area. Using nitrogen in poorly ventilated area can result with suffocation. Caution: as noted in Table 2, compressed air nitrogen source cannot be greater than 200 psi gauge. Alright, attach the air nitrogen hose to the inlet nipple. Make sure there is a firm connection on the air nitrogen is properly attached and push down. Turn the air regulator knob clockwise until the pressure of the air pressure gauge indicates between 5 and 7 psi gauge. Plug in the power cord, appropriate ground power supply. Set the power switch on. The power lamp and the heated air lamp will both illuminate. If the lamps do not come on, check the switch for the gun handle. If the switch must be positioned toward the front of the handle. There's 1 minute warm-up line time. During the warm-up period, ensure that the indicating air pressure is increased to 10 and 15 psi gauge air pressure gauge. You can now adjust the temperature control knob to the desired temperature setting. You can turn the air nitrogen pressure off on the gun without powering down the module using switch mounted on the gun handle. After you complete the task, complete rest air nitrogen heating tool, use the following shutdown procedure. 1. Push down fully, turn the air regulator knob counterclockwise, observe the air pressure gauge indication drop to 0 psi. The heated air lamp goes out. Position the switch and the heating gun towards the rear of the handle. Place the power switch in the out position. Observe the power lamp goes out. For the air nitrogen to follow with a minimum of 1 minute to cool the heating gun. This procedure is done to extend the life of the heating element. 5. Disconnect the power connector with the power source. Turn off the air nitrogen source to place of the origin or disconnect. Disconnect the compressed air nitrogen hose from the air inlet nipple and install the dust cap on the air inlet nipple. Non-insulated copper terminals. The procedure for the crimping of copper terminal non-insulated with the copper wire is followed with a wire strip to determine the insulation of the wire over 1/32 of an inch longer than the length of the terminal barrel. When you use the wire stripper, be sure to use the correct side of the stripping slot with the wire size. Otherwise, the insulation would not be removed. If in the slot is too small, outside strands of the conductor will be nicked, consequently weakened. The knife that is used with the stripping wire carrier should be used to prevent nicking of the strands. Slip the spaghetti's heat shrinking tube over the wire and be it back far enough to be out of the way with the crimping operation. To slip the terminal over the bar wire and bared wire end up against the insulation. Make certain that all the wires are inside the tubular barrel on the terminal. Certain terminal barrel in the female nest of the plier jaws are shown in Figure 212 so that the indented form of the staking die will be greater than the center of the barrel. Crimping under the pliers, reaching the stop limit if necessary. Good mechanical electrical connection. 4. Strip the tubular insulation down over the terminal barrel so that it extends a little beyond the barrel. Tighten the place in the spaghetti. Use the heat shrinking tube to use shrinking the heat gun with a heat gun. Alright, aluminum terminals and splices. Alright, aluminum terminals. Alright, yeah, we're getting enough sound. Aluminum terminals and splices. Terminals that use aluminum wire made of aluminum. Proper crimping is more difficult with the terminals because of the such factor with aluminum creep and softness. Aluminum wires have an undesirable characteristic called aluminum creep. Aluminum has the tendency to actually move away from the point where the pressure is applied. This is not only during the crimping operation, but also takes place during the temperature changes. The aluminum wire is softer than the terminal lug splice for the connectors and contractors faster than the connector when the temperature drops. The cause of the wire to creep away from the crimp connections, which in turn cause the loose of connections. The softness of the aluminum wire, it always makes it subject to being crimped, subject to being cut and nicked during the stripping. You should be careful never to use an aluminum terminal with a copper wire or copper terminal with aluminum wire because of the electrosis. Electrosis is a chemical action that takes place when the electrical current passes through the two dissimilar metals. The chemical action corrodes, eats away of the metal. They always never use the aluminum crimping tool with a crimping. Also never use aluminum crimping tool with a crimping other than aluminum terminals. Aluminum terminal lug splice are non-insulated, so you must use spaghetti heat shrinking tube for insulation discussed earlier. The barrel several times larger side of the aluminum terminal lugs are filled with petroleum abrasive compound. The compound causes the grinding action during the crimping operation. This removes the oxide film from the aluminum. It also prevents oxide film from reforming in the connection. Aluminum terminal splice having an inspection hole to allow the checking of the depth of the wire insertion. The hole is sealed with a removable plug, which also serves to hold the oxide inhibiting compound, Figure 217. So you have your inspection plugs, aluminum splice, inspection plug, aluminum terminal. Is recommended Figure 217 shows aluminum terminal lug and splice. Okay, it is recommended that only power-operated crimping tools be used to insert large aluminum terminal plugs and splices. See View A, Figure 218 shows power crimping tools, electrical hydraulic pump die box, electrical hydraulic portable stationary hydraulic hose control cable, hydraulic pedal pump, hydraulic manual, and the crimping. The steps used for the crimping aluminum terminal splice or splice with aluminum wire Figure 218 as follows. Carefully remove the conductor insulation. Do not cut and nick aluminum conductors. Do not wire brush or scrape aluminum conductor. The compound with the terminal splice barrel will clean satisfactorily. Remove the protective foil wrapping with the terminal splice and check the amount of the compound in the terminal barrel. It should be 1/4 of the 1/2 full. Slip the spaghetti heat shrinking tube over the wire with the back far enough to be out of the way with the crimping operation. Insert with the strip the conductor with the full length of the terminal splice barrel. While doing this, leave the plug over the inspection hole. This allows the compound to be forced around the strands. 4. Center the terminal lug splicing the crimping tool. 5. Actuate the proper crimping tool. 6. Wipe off the excessive compound. Inspect the joint of the probe of the inspection hole. The end of the conductor should come to the edge of the inspection hole. Strip the tube and insulator down over the terminal and splice barrel. Tie it in place with the spaghetti as using a heat shrinking tube, shrinking and a heat gun. Improper crimping procedures eventually cause terminal failure because they are especially careful with the undercrimping, overcrimping, use the wrong crimping tools, improper cleaning method, cutting or nicking of the conductors, as loose contacts allows the oxidizing film to form between the wire and the terminal. The result increase the resistance and the resistance causes the heat. The heat accelerates deterioration, eventually failure results. Are your pre-insulated copper terminal plug splices? Use the pre-insulated terminal lugs and splices have become the most common method of copper wire termination and splicing in recent years. It is far best for the earliest method. There are many of the tools used in the crimping terminal lugs and splices, and portable solid stationary power tools are available with the crimping terminal lugs, whether they're tool crimp or to the barrel to the conductor at the same time. The insulation support of the wire with the insulation. The power of the tools, both stationary and portable, used found in large shops where wire bundles are made up. The next paragraph will discuss the more common hand tool crimping tools you must be likely to use in your day-to-day work. Terminating copper with wire pre-insulated terminal lugs. Small diameter coppers are terminated solderless pre-insulated copper terminal lugs as shown in Figure 219. The insulation part of the terminal lug extends beyond the barrel so that it is covered the portion of the wire insulation. This makes the spaghetti heat shrinking tube and necessary pre-insulated terminal lugs also have insulation support and metal reinforcement sleeve. Beneath the insulation extra support strength is wire insulation. Some pre-insulated terminal fits more than one size of the wire. Insulated color code range of the wire size marked on the tongue identifies the wires that can be terminated each for the terminal lug. See Table 2.2. Figure 219 shows the pre-insulated straight copper terminal, the wire insulation, color-coded insulation, the insulation support, the barrel, the MFRs, manufacturer's mark, the striped ped wire, stripped wire, the tongue, and the range of the wire size. The color-coded terminal lug is yellow, bright at 2624, red at 2220, and 18, blue at 1614, yellow at 12 and 10. For crimping smaller copper terminal, several hand crimping tools can be used with the wire side of the American wide gauge, American wire gauge 26 through 10. Figure 220. The hand crimping tool is self-locking ratchet when prevents the tool from opening the tool until the crimp is completed. Some of the other tools are color-coded selector knob to match the color-coded terminal as splice is being used. Other tools have replaceable sets of dies for several wire sizes. The hand crimping procedure of the pre-insulated copper terminal lugs in wire sizes number 26 through number 10 with a standard hand crimping tool as follows. Alright, 220 shows the hand crimping tools fully closed position, the wire selection knob, and also stripping the wire insulation. Even the recommended stripping procedures always discussed. Ensure the tool handles are fully open. The proper die set has been installed correctly. Insert the terminal lug tongue first and then into the wire side of the hand barrel, crimping the jaws. Be certain the terminal lug barrel butts flush against the tool set with the locator. Figure 221 shows the correct installation method. The terminal locator on top side. Squeeze the tool handle slowly with the tool jaws. Hold the terminal lug barrel firmly in place without denting it. Insert the strip wire in the terminal lug barrel until the wire insulation butt flushes against the near end of the wire barrel. Figure 222. Proper installation, strip wire insulation, terminal lug, and crimping. C equals the insulation of the barrel, and B equals the barrel, the wire strip length, and then the finished crimp. Squeeze the tool handles and the ratchet least. Remove the completed assembly. Examine the proper crimp according to the following: indented center of the terminal lug barrel, indent in line with the barrel, terminal lug not correct, terminal lug insulation not correct, insulated grip crimped. Caution: is not properly stripped. Some of the smaller gauge thin wire insulation can be invertedly inserted, crimped in the terminal wire barrels. This will cover the bad electrical connection. Do not use any connection found defective in this result. Visual inspection: cut up the defective connection and make use of the new terminal lug. Pre-insulated splices. Pre-insulated permanent copper splices are used to joint smaller copper wires. American wire gauge number 26 through number 10. The typical splice is shown in Figure 223. Note the splicing and pre-installation extends over the wire insulation. Each splice size can be used for more than one wire size. Splices are color-coded in the same manner as pre-insulated smaller copper terminal lugs. See Table 2. Color-coded insulation support barrel. Crimping procedure for splices. Crimping small pre-insulated copper splices for the number 26 to number 14 wire size can be arranged to accomplish several recommended tools. This section will discuss basic crimping procedures. Alright, strip the wire length following the one over the procedures also already discussed. With a tool handle fully open, select the wire slide selector knob with the proper position of the wire side with being crimped. Slide the terminal lug down below the die surface in the fully retracted position. See Figure 224. Slide the slice locator with the retract position. Insert the splice from the tool, locating the shoulder on the side of the splice to the crimped in space between the two crimping dies. The insulation barrel on the side of the splice should be protruded to the wire side of the tool. See Figure 224. Slide the splice locator in the fully extended position. Insert the splice from the stationary die so the locator and the finger fits and locator groove in the splice. Alright, Figure 224 shows locating the splice with the crimping tool. You have your stationary die, your movable die, your selector, and your selector plate. The two splice locators, terminal locator retracted, wire side, and the wire crimped terminal lug retracted from inline splices. Or squeeze the tool handles slowly. The tool jaws hold the splice firmly in place, but without denting the barrel. Insert the strip wired in the splice barrel, with which protrudes the wire side of the splice until the strip ends and the wire butts against the top of the center of the splicing. This can be thoroughly spliced in inspection window. Crimping and closing the tool handles to the loop will not open fully. Crimping cycle has been completed after the crimping. Check for the wire end. It is still visible with the splice inspection window. 7. Reverse the position of splicing with the crimping tool location with the crimping tool on the splice. Repeat the steps 1 through 6 with the crimping wire on the other side of the splice. If the correct tool is used, or used the proper procedure followed, the crimp-on connections are more effectively electrically and as well as mechanically. They are solder connections. Visual inspection very important. Reveals oxidization, deterioration, overheating, broken conduction. In some cases, many necessary to check with the connection with the ohmmeter. Proper resistance. All practical purpose should be at 0, and a defective terminal should be removed. The terminal crimped on. Alright, soldering. We can cut the tape there.